Hi, today we are going to start chapter for class 11, that is complex number. Okay, complex number and quadratic equation. So first I'll tell you in this lecture some part of complex numbers. Okay, so let's see what is that complex number. Complex number is a number which is denoted by z, and it is in the form of a plus ib. Okay, so here your a is called a is a real part. Okay, a is a real part and b is also real part. Real part means real number, by the way. Okay, so this a is a real part and this ib, this whole, is called imaginary part. Okay, and a and b are real number. Real number means it can be -1, it can be minus half, it can be root 3 also, anything. I mean, apart from I is a imaginary part. Okay, I'll tell you the value of I also. Okay, so here let's say we can write z as 2 plus 3i. Okay, so this is a complex number, by the way. Okay, so suppose you have two numbers like z1 is equal to 2 plus 3i, and z2 is equal to 3 plus 9i, and you have to add them. Let's say you have to add z1 plus z2, so you can just easily add. Z1 is 2 plus 3i and z2 is 3 plus 9i, so just add it, 3 plus 9i. So it will be added and it will give you the answer as 2 plus 3, that is 5, and plus 3i plus 9i. Just add the, like, 3 and 9 is 12, and just put the I, sorry, like this I, because 3i plus 9i means I just take common, and 3 plus 9 like this, so that is 12i. So answer is 5 plus 12i. So you see, when we added z1 plus z2, you got another different z. Okay, you can call it z3. So this is z3. Okay, clear, right? So now this was addition. Now we can do subtraction, multiplication and division also. Okay, so let's say we want to subtract z1 minus z2. So let's say z1 is 3 plus 2i. I'll take another value so put it in a bracket because it's a subtraction, right? Then minus z2, you can write, let's say, any number, 3 plus 5i. So 3 plus, just break the bracket to 3 plus 2i minus 3 minus 5i. Okay, so 3 minus 3, this will cancel, 2i and minus 5i, that is how much? Minus 3i. So you see, this time you got a number. This is also a one complex number only, which is, let's say, z3. But here, if you see, let's say we want to write minus 3i in the form of a plus ib. So we can write like this: 0 plus and I into b. B is minus 3. So like 0 minus 3i. So this is a format of complex number, like a plus ib we follow, right, in that format. Okay, so this is how we do the subtraction. Now if suppose you want to do the multiplication, let's say, let's go to multiplication. Okay, suppose we have z1 is equal to 3 plus 3 minus I, and z2 is equal to any number you can do, 5 plus 2i, and we want to multiply it. Okay, so just multiply here. So like this: 3 minus I bracket 5 plus 2i. So 3 will multiply with 5, that is 15. 3 will multiply with 2i, that is 6i. Then minus I into 5, that is minus 5i, and minus 5 minus I into plus 2i, that is minus 2i square, I square. So I square value is always, remember, minus 1. How? Because I is equal to root of minus 1. I will tell you this. Okay, how I is coming minus 1, that part I will tell you later. Just remember that I is equal to root of minus 1. Okay, so if you do the square, like let's say I is minus root of minus 1, and if you do I square, so it will become minus 1. So that value I'm keeping here. Okay, so then 15 6i minus 5i, that is I, and this is minus 2 into minus 1, that is plus 2. This 15 will be added to 2, 17 plus I. So the answer will be 17 plus I. So that is the multiplication, Z1 into Z2. Okay. Now, after doing this multiplication, let's see some division. Let's say I want to do Z1 by Z2. So Z2, let's say Z1 I'm taking 3. I think you can take 3 minus I divided by 5 plus I want to divide it. Okay. So for division, I'll do the this method. I'll just take the reverse of this number. I'll just change the sign of this 5 minus I, and I can write here 5 minus I, because if you do this, nothing will change. So, and then you just multiply this and this, numerator, denominator, multiply, and whatever will come, that will be the answer. Now, so let's see, 3 into 5, that is 15. Then 3 into minus I, that is minus 3i. Then minus I into 5, that is minus 5i. Then minus I into minus I, that is plus I square, that is I square is minus 1, right? So plus I square minus 1, I have written in a bracket. And divided by, you see here, this is a plus b into a minus b. So a plus b is, a minus b is how much? A square minus b square. So just put it in 5 square, that is 25, minus b square is b square, b is high, how much? I, right? I mean b is full I, right? So I square minus 1. So I'll put it like this. Okay, so then you see here, this was minus 8i, so and this is minus 1. So 15 minus 1, 14, and this is minus 8i. So right here, 40 minus 8i, and this is plus 1, so 26. So we can just bifurcate it like 14 by 26 minus 8i by 26. So like this is A, this is full is A, and this is B. So your A is, they can ask you like what is A, what is B. So you can tell A is 14 by 26, B is minus 8 by 26. And this is the, like when you're doing Z1 by Z2, you are getting a new Z. That Z, you can call it Z3. You can name it. Okay. So we have seen today in this session Z1 plus Z2, Z1 minus Z2, Z1 multiplication with Z2, and Z1 divided by Z2. In the next session, we will do we'll understand why I is equal to minus 1, root of minus 1, and we'll do modulus. There is a concept called modulus and argument, and conjugate and polar representation, organ plane. So all these things we can do in next session. For that, you can just practice the basics of complex number, and I'll see you in the next class. Thank you.